Thank you. Yeah, so I'm Alex, the Entrepreneur. This talk is called Fuzzing Liquity. And as you already heard, I previously worked at Badger. I'm currently a lead security researcher at Spearbit, and I co-founded Recon, which is a boutique audit firm that specializes in audits that are backed by invariant testing. As of today, I received about $500,000 in public awards, and my proudest achievement was preventing a critical exploit on live contracts this year for about $20 million. Amongst our returning customers, we have Badger, Centrifuge, Corn, Liquity, and Balancer DAO, and many more. And in terms of what we do at our company, we do audits, and we also do invariant testing as a service, which fundamentally means we set up this specific type of tests that help us explore combinations in smart contracts in order to find bugs. We also have some custom deals where we, first of all, allow you to run the invariant test in the cloud through Recon Pro, but we also have monitoring as a service. And it's actually something I'll talk about tomorrow, of how we use invariant testing to predict exploits instead of detecting them. First of all, about this story, this is based on public available facts, but everything I'm going to say never made it to prod. The Liquity team originally engaged us to help them both audit and write the V2 governance contract. And because of their thoroughness, everything that I'm going to show never made it to prod. They actually changed their smart contracts in order to remove the issue that I'm going to talk about. And this is really the story of this specific line. If you've been fuzzing smart contracts as much as I have, you will know that any division creates truncation, which means that the machine actually deletes the data that is divided. You basically lose the remainder. And we're going to see how that line ended up causing about $100 million in inflated votes for their contract in their previous iteration. So before I can talk about the bug, I'm going to need to give some context about how the governance.sol contract works. And first of all, Liquity actually chose not to use VE, which is voting escrow or vested escrow, which is the most common governance contract available in DeFi. And the way voting escrow works, it fundamentally forces a user to lock their tokens. And based on the amount of time for which they lock their tokens, they end up getting voting power. Whereas the way the Liquity V2 governance contract works is based on what I like to call voting power. Fundamentally, whenever you deposit some Liquity token, I mean, first of all, they chose not to deploy a new token. They actually kept the original one. Then they actually wrapped their original staking, the V1 staking, on top of the V2. And the V2 mechanism looks a little like the chart that you can see provided by Chain Security, where fundamentally, as time passes, you increase in voting power. And the slope of these lines is equal to the amount of liquidity you deposited, whereas the value is determined by the amount of time in which you left your liquidity staked. And so this is effectively a soft lock where you can withdraw at any time, and you will lose the voting power. You can see that it falls down to a lower value. But you also have these mechanism that makes it so that you cannot flash loan voting power. If you were to deposit some tokens in the same block, you would actually end up getting the same voting power, and then you would actually lose it the second you withdraw. And so we can simplify our voting power formula to this, which is basically now block.timestamp minus the average age, where average age is effectively the average age at which a user deposited their liquidity. If I did a single deposit, I will get the average age of my deposit, whereas if I start depositing multiple times, I will get some sort of a weighted average based on the amount of tokens that are deposited. And so the key mechanism is kind of this novel mechanism, this interesting formula, which I guess I'll go back for a second, but it's going to come back later. But fundamentally, it all boils down to having a previous outer average timestamp, a new inner average timestamp, and then doing some math to effectively find a mean, a weighted mean among those two. And so this is really cool because it's a new mechanism. It also is a soft lock, and they also didn't deploy a new token. They actually made their original design work. And so we were basically tasked to help fix a bunch of bugs. And in doing that, we ended up writing a part of this. And I'm going to kind of go through some of the bugs that we were presented with. This is all from the Chain Security Audit Report, which was given to us for version V1, and that we contributed in building version V2, whereas the deployed version is actually version V3. So one of the bugs that we were presented with was this initiative votes overflow. Fundamentally, a initiative state was represented as a uint 88, whereas the function allocate liquidity could be used with an int 176. Hopefully, it's pretty straightforward to think that you can truncate a uint 176 into a uint 88, and you can actually cause an overflow. And so this was effectively an overflow. There are many ways to catch this type of bugs, but one of my favorite ways is to have a global accounting property that effectively checks that the math was sound before an operation, and then it checks that the math was sound after an operation. So this is an example of a bug you can also find with formal verification by applying the weakest precondition. You just ask the tool whether it can generate you a precondition in which you have an overflow, and you should be able to find it fairly easily. So this was not particularly difficult to fix, but this is something we were presented with. The next bug was effectively a typo in a struct, but it points to the same issue, that the global accounting math was unsound, and most importantly, was untested, which is, if you actually read the Chain Security Report and the DDoB report, they actually the quality of the testing of the code base was praised, partly because of our work as well, which we helped boost that quality. And something else that I thought was extremely interesting, but it's not as impactful as these overflows, was the vote tallying being incorrect. Fundamentally, based on various states that the governance contract could be in, you would actually see that the contract will tally the votes differently. So the total votes would actually change in a way that was inconsistent. And so whenever we think about this idea of a state and effectively some sort of aggregate value to discuss this state, then you want to think about the high-level idea of having a finite state machine. And this is something that the moment I started seeing these bugs, I really thought about how the contract needed to have an explicit state machine, and I'll show you what I mean very soon. We also have another issue tied to the finite state machine, where deallocating from a disabled initiative would effectively break the global state accounting property. These tend to be somewhat semantics, because at the end of the day, whether you should count or not count a initiative or its votes is not particularly relevant. However, what's relevant is that these type of inconsistencies can compound, and they can also be solved fairly elegantly. So in general, whenever you have this type of bugs or this type of reports, you want to address them by changing the design of your smart contract, which is what we did. We also have this quirky bug. If you check, the solution is inspired by some of the work I did in various contests for optimism, but we basically took their optimism library for safe call with mean gas, and we basically made it so that initiative couldn't grief by burning all the gas, which is just a cool bug. And so we were presented with quite a few. You can imagine that there were actually more, and we also found more as we started working on the code base. And so whenever you're tasked to do a massive amount of work in very little amount of time, you want to think about invariant-driven development, which is what we actually did and what we are advocating for. We're not the only ones, but we definitely are. Hopefully, we are leading by example with this. And so the key idea of invariant-driven development is that we can look at a smart contract, for example, the governance contract, and that we can define some sort of bounds for the behavior of that contract. And so what I mean is that we can look at, let's say, the soundness of the math, or let's say that the total votes should always increase. We can look at something that is that elegant and that simple. We can write a simple property, and that we can structure our CI/CD in a way that that property is always checked, meaning that even though we start with something really wide, right? We cast a wide net for behavior. We're slowly reducing the amount of variability and the amount of complexity that the contract can have by doing that. And the key part is also that having that allows us to iterate faster. And anytime we reintroduce a bug, which obviously can happen, I can type, make a typo, make a mistake, or do a merge incorrectly, we will simply rerun the suite, and we will effectively immediately notice that we introduced the bug again. And so in practice, what this looks like, it looked like scaffolding the suite. Back when we were working on this engagement, we had the original version of the Create Chimera template, something we open sourced on our GitHub. We currently have the second version, which is a lot easier to use. And the other aspect is having a big corpus. That's based on a fallacy on how people use these tools. When you run a benchmark on something like Echidna versus Foundry, Echidna will always lose the benchmark for finding bugs. It's actually is literally slower than Foundry. However, in practice, because of the fact that Echidna has corpus reuse, meaning that it learns from its previous runs, in practice, Echidna is always better for developers that actually work on the code base. And that's why every single professional uses Echidna, or I guess every single is a bit an exaggeration, but the vast majority of people that do this professionally do it. And so the last part is debugging broken properties. This was created by my co-founder, Antonio Vigiano. Basically, we use a template that connects Foundry with Echidna and makes it so that anytime a tool such as Echidna, Medusa, even Halmos and Control break a property, we can quickly get a Foundry repro, meaning that we run the tool because it's better, but obviously we use Foundry because we're not, we like Foundry. It's a really efficient way to iterate on smart contract. And so when it came to fixing the first bug, the overflow, we simply changed the allocate liquidity to have a type that was closer to the intended goal of a uint88. And then you can see that we have a simple check for recording non-negative. So that was a very straightforward fix. Whereas when it comes to the typo in the causing an incorrect calculation, we basically added a property called property sum of user voting weights bounded, very verbose name, but we fundamentally just sum up all the votes and then verify that within a certain tolerance, the votes match up. This tolerance is going to come back later. And then when it comes to the finite state machine, something that I'm pretty proud of is I basically made it fully view, or I tried my best to make it a fully view set of view functions that given some state will basically return the current state in the form of a global state, and then the snapshot, meaning the state that was actually snapshotted at a specific time, and it will then tell you whether it needs to be updated. So we effectively have a cache or a rolling cache that tells you whether you should actually call the storage altering function to alter it. And then I tried my best to make this get initiative state function fully stateless. It's not exactly stateless, but it's fairly close, and it makes it so that we can just pass these internal storage values, and that we can effectively get all of the possible states that the contract can be in. And this mapping this inner contract to our properties makes it so that we can quickly write a few properties to specify behavior. And this is a really convenient way to ensure that the contract behave in a way that is intended. And you can see that there's actually quite a few, but given any initiative, we can then assert that it will behave as we intended with the specific status being consistent. And the status, getting the status is as easy as calling get initiative state. So it's a very easy test to write once you restructure your smart contract in that way. And so all we were left with after spending 2 weeks and a half, almost 3 weeks in fixing the bugs, rewriting the code, doing all the invariants and all, was really this line. And this was the impact that we had. QA, low severity, average timestamp can be off by 1 second. And the Chain Security, the team at Chain Security actually did a great work in attempting their best at changing this impact. And I think they actually wrote a really interesting report. It's poorly pasted here, but you can find it on their on the audits from Liquity. And so our side, what we did is we repurposed our suite to ask Echidna what was the maximum impact that it could generate. And so this is kind of the meat and potatoes of the talk. And the most interesting part is really that all engagements almost all end up working in the same way. And what I'm advocating is that you basically watch these next few slides and then immediately use optimization mode for Echidna, basically. But fundamentally, we have this global property called property sum of initiative. Initiative matches the total votes, which fundamentally will sum up all the votes that are being used and then all the votes that are stored in the state, and it will assert that they match, which is something that should typically happen for most governance and other types of protocol. And we basically saw that Echidna was able to break it, but it will break it with a small value. So you would only get like an error of 2, an error of a few thousand ways, so it wasn't particularly relevant. And so whenever you're met with this type of broken properties, most engineers will simply add a tolerance, something like 1E8, 1E18, saying, okay, it's off by 1 liquidity, who cares? We did 3 audits, let's just be done. And that's really it's also what we did. But because of my expertise in this, I just couldn't stop at this point. And the reason why this happens is really that all these rounding errors, they tend to be swept under the rug. They typically get accepted as low severities, and most projects stop. And what I'm advocating is you instead convert these to an optimization test, which is what we did. We literally took our previous function, created a simple internal function so we could grab those values, and then we followed this simple template of having a optimization function, which needs to return a signed integer. And we have one optimization function called insolvent and one called underpaying. An insolvent optimization function leads you to a critical bug. An underpaying one simply means that there's probably a rounding error. So it's typically okay to have an underpaying contract that shorthands every user, but having an insolvent one can be really problematic. And another pattern that we saw would be using thresholds such as 118 or dividing by basis points for you to gauge the value or gauge the size, the relative size of these. And so off of these, running the optimization suite, we effectively, as you can see, we have a very simple property, really elegant, really simple to write. And we had to shrink it. That's because Echidna is really clunky software. And we run into this bug called the zero calls bug. Basically, anytime one of your optimization properties is broken or is optimized with 0 calls, Echidna actually breaks. And the solution is really to just comment out every property so you can actually do that. And off of that, we actually got this fairly readable repro, still somewhat rough, but at the end of the day, it really boils down to having a user performing a big deposit, waiting some time, I think it's about 1 week, and then deploying a new initiative and then performing a vote on that new initiative. And fundamentally, in doing that and voting with 100% of a user voting power, we then, since we're using Foundry, we can quickly debug it by using console.log, although one day hopefully we'll get the runtime verification debugger to work with cheat codes. But off of that, you can see that we still are off by 1 second. And in this case, we were off by 1 second when comparing the global liquidity average timestamp versus the average staking timestamp of the initiative. And what that does is it means that this 1 second error could be off for every user. And in this specific example of depositing a bunch of liquidity and then waiting a week, it would actually, an error that will start as about 15 liquidity will actually be magnified to about $151 million of liquidity in error. And so whenever you're presented with something like this, which from my perspective, we could have spent months fully investigating this into a critical bug by building various preconditions. But whenever you're presented with this, you want to basically look at the root cause, which in this case was this truncation on the votes over new liquidity balance. And then you want to make the difficult decision of rewriting the math. And that's what the team at Liquidity did. They basically were faced with shipping an unknown bug that could probably be magnified, or simply changing the formula and writing it from first principle. And that's what they did. They changed it to this unallocated liquidity and unallocated offset, basically a slope plus offset formula, which still carries some rounding error, but it is massively smaller than the one that that we had on the V2. And so, yeah, as a conclusion, my biggest advice is to try fuzzing, and most importantly, use optimization mode for Echidna whenever you end up having a rounding error as a means to escalate it. Thank you for having me.
Okay, thank you, Alex. So now we have a few minutes for questions, if any. Please raise your hand if you have. Okay, we have one question there, and then after, behind.
So I'm curious, in this engagement, did you have to invent invariants, or did the developers give you some of the invariants?
The invariants?
The invariants, yeah.
Okay, so no, I wrote all the properties myself. The specification from the team was, there was some documentation, and also we collaborated with Chain Security to ask them, because obviously once you set this up, you can, the impact of an auditor is massively helpful. But I wrote the vast majority of the properties myself, and I think I guess one side effect of this talk is really this idea of the solvency formula. Most contracts have some sort of a solvency formula where you have a user, like a running sum of user states, and then a global total accounting, and you will always want to compare them. So it's actually a fairly common pattern for properties.
Thank you.
Great talk. Hey, it's really difficult for a lot of us to start fuzzing. Is there anywhere you know of where we can kind of go to just making fuzzing easier, just to maybe even fuzz from our GitHub?
I'm glad you asked. Definitely come to getrecon.xyz/Riptide for the best fuzzing engagements to get $5,000 off your first engagement. But yeah, jokes aside, we have book.getrecon.xyz. Originally, we used to do office hours where every week I would improvise a talk on the topic. There's a bunch of them on my YouTube channel, on YouTube, Alex the Entreprenerd. But we basically took the best of them and we put them in a book called book.getrecon.xyz, and that's where we plan on putting all of our open source and playbooks. So if you had to check one resource, that's probably the best one to get started. And most likely will lead you to using our extension called the Recon extension, which we basically made it, once you have a Foundry project, you just click a button and it scaffolds the suite for you. It's not going to do the entire work for you, but it definitely will get you very far if you want to get started on something simple.
We have time for one more question. I think I saw a hand on the right. Oh yeah, I think Sukhir was first earlier.
Thank you for the talk. I know often people get too focused on tools, but I will ask about tools. Do you still see Echidna as the go-to? Is Medusa coming up? Is there any other tools I don't know about?
Yeah, I would say as of today, we still use Echidna on the daily. However, for specific use cases, for example, for forked mainnet testing, Medusa is actually better, but only if you have a local node. So Medusa is starting to become better. I think Trail of Bits will consider it comparable. I still think Echidna is slightly better today. And as far as I know, Foundry, Alpha Rush, who used to be an engineer at Trail of Bits, now works at Asymmetric Research, is working on making Foundry stateful. So the day Foundry stateful, you probably should try it day one. Until then, I think our setup is the best because we break it with a tool that is specialized, and then we send you back to Foundry for the debugging, which I think is the best experience today.
Let's try to. Is your question minute enough? Maybe. Yeah, let's try. Let's try.
Yeah, thanks for the talk. You mentioned in passing something that's also a social problem, which is especially in contests, these small errors often get swept under the rug. Do you see any chance for using automation to make, get more signal on these things that teams often don't engage with in an audit?
Yeah, I think if you've tried Scribble from Consensus, I think Scribble tried to solve the issue of writing properties, but fundamentally added a new language. I have given up on using a new language, but I think with some work we should be able to make it so that our extension, you basically double-click on a function, and then you click on another one, and then it automatically scaffolds an optimization test. I hope that's how we make it easy, but there's no escaping the fact that you need to be able to run the tool, understand how it works, understand the weirdness, and so it's fundamentally, it's very easy and very good if you're willing to learn, but if you're not willing to waste about 4 hours for this stuff, I think it's, there's a massive gap there in making it easy for everybody to use.
Okay. That's it for the Q&A. Let's give Alex a big applause. Okay. I'm going to tell everyone, all my cool friends use
The Recon extension.
like